Hey guys, Rudi back again with another CSSE1001 and 7030 tutorial video. Now this week we're going to be looking at the week 3 tutorial, which is all about turtles. Okay, now I'm a pretty big fan of turtles myself, so I'm going to quite enjoy this tutorial. But essentially what we're going to be doing is using a module, more on what a module is in a second, to essentially move this little turtle guy around the screen and try and draw some shapes and get a better idea of how to use functions and modules in Python. Okay, so what's a module? Essentially, Python, when we're just messing around in the shell and writing singular scripts and all that sort of thing, Python doesn't have its entire code base sitting there, right? A bunch of Python is separated out into these modules that we don't always need to use, right? So think about something like if we're using maths, if we're using Turtle or something like this, right? These aren't things that we always need to use. So by default, Python doesn't necessarily always have access to them, right? And this allows Python to stay a lot lighter and a lot faster, right? Instead of having to lug around all this extra code with it. And then when we want to actually use maths or when we want to use the turtle, we import them, we import this module into Python, and now we have access to all the sort of functions and classes and stuff that come with this module, as we call it. Okay, so I'm gonna just copy this stuff here straight out of the tutorial. Okay, so we can see, whoops, we have imported the turtle module. Okay, and so now we have access to a whole bunch of functions that belong to the turtle class, such as turtle forward, turtle left. You can have a bit of a read of them over here in the cheat sheet. But for now, I am going to quickly save this guy as tut2.py. Fix that up later. Okay, and let's just run this and see what it does. Okay, cool. So that was a bit jaggy. You can see that we spawned up our turtle. He started over here, and then he went forward, right? Let's just follow what's happening here. We went forward. He turned left 120 degrees, so that's a bit more than a left turn, right? He's gone a bit far past it. He then went forward again for 80 units. He's then turned right 90 degrees, and then he's gone forward again 80 degrees. And this exit on click guy basically just means that when I click on this now, it all closes down. Now, running this command more than once can, if I remember correctly, can have a lot of problems in Turtle. So I'm instead just going to chuck this right down the bottom here so that we never use it more than once. Okay, so you can have a bit of read here, but basically turtle forward makes our turtle go forward, left and right, turn it by angles. We've also got a couple others here, set heading, reset. You guys can have a bit of a play around with those more. I'm just going to get straight into these exercises we've got here. Oh yeah, this is something else that is actually quite important to note. So do not save your file as turtle.py. Right, so see how I've called mine tut2.py? The reason we do this is because when we call import, right, so Python's first sort of thing that it looks for when you go import turtle is it looks in the folder you're in. And it says, well, is there something in here called turtle.py? And if it finds nothing, then it instead sort of looks a bit further, it looks a bit deeper into Python, then it goes, oh yeah, cool, there's a turtle module here, right? But if you call this file turtle.py, it'll actually try to essentially import itself, if that makes sense, because Python will go into the folder and be like, oh yeah, there's a file here called turtle.py, right? And so when you try and import the turtle, you'll find that it has nothing in it because, well, you haven't written anything, right? The only thing you'll have is this demo function. So just be careful of that if you get a bunch of things which are like turtle isn't defined or stuff like that. But we're going to try and write a couple of functions today, just to draw some shapes and play around with the turtle a bit. So what's this first one we've got here? Rectangle. Okay, so we want our turtle to draw a rectangle with the specified width and height. Okay, and ensure that the cursor finishes pointing east. Okay, so that's the sort of last thing to think about. So we've got this width, and we can see that our turtle is going to draw out this shape. Then he's going to turn left and draw, go left and draw, and go left and draw. Okay, so he's going to have to start off by going forward, right? Because we saw before that the turtle starts in the middle of the screen facing right. So if we want him to draw this length here, well, how long is that? Well, that is the width of our rectangle, right? So we want to draw our turtle forward.width. Okay, let's just quickly check that. So what have we got here? Rectangle. What was it, 80, 40 in their example? Okay, so let's just see what we're doing so far. turtle things. And then, yeah, there we go. So he starts to the right and he's drawn our first side. Okay. So let's go back to that. What's the next thing we want to do? We want to draw this side length right. Now the turtle can't just move left. The turtle only moves forward. So we instead have to adjust the way he's facing. Okay, so we can see he's turned to the left. And now since this is a rectangle, the angle at which he's turning to the left is going to be 90 degrees. I'll actually show you something that happened again there. We can see that idles actually popped up. Oh yeah, you want an angle, turn turtle left by angle units. And the reason that that's popping up is because of the documentation that's associated with the turtle class, or the turtle module. So if you're ever unsure and you're using some sort of foreign module like this, you can always just sort of stop at that opening brackets, and generally idle will give you some sort of indication of what's supposed to go in there. Okay, so we can see that after we've gone forward and we've turned left, we then need to draw the next side of the rectangle, right? So we're going to be moving forward again to draw the side. Okay, and then we want to do this, what? This length here is going to be the height of the rectangle, right? So we want to move the turtle height. Okay, let's just always checking as we go. Yep, we can see we've gone forward, we've turned left, and we've gone up. So our rectangle seems to be going the way we want it to. Okay, so at this point, it's sort of just a bit repetitive, right? Because it's a rectangle. Going to turn 90 degrees again. And then we're going to do more or less the same thing. Okay, forward, left, forward, left, forward, left, forward. And now this final thing here says that ensure that the cursor finishes facing east. Okay, so we want to make sure that regardless of what happens, we end up facing east. Now there was a command up here before. Yeah, this one, set heading. Sets the turtle's direction in degrees, 0 is east. So this one just forces the turtle to end up always facing east. Oops. Save this guy. Oh, and there is our beautiful rectangle. Excuse me. Okay. It's actually really small. Let's just pump this up a bit. On a nice thick rectangle. Yeah, there we go. Okay, now obviously there's a couple of ways you could have done this. This is the easiest way of doing it. There's no reason why we couldn't have made our little turtle moonwalk around the rectangle. You know, like if we have def moonwalk rectangle. Okay, and we can use, instead of going forwards everywhere, we can do pretty much the same thing, but instead make the turtle go backwards. Now, there's no real reason for this, but I had someone request this, so I'm going to chuck this in anyway. Let's use backwards, backwards, backwards. Okay, let's see. Oh, whoops, I'm still calling the same one. Let's use our moonwalk rectangle. Turtle dot back, is it backward? Oh yeah, it would be because it's forward. Okay. Notice here that the error message here said turtle has no attribute backwards. Okay, so we can quickly check our function up here, and we can see that, oh, it's turtle.back. Yeah, even better. See, this is why you read the documentation, guys. You don't make silly mistakes like this on recordings. Turtle.back. Woo, look at the moonwalk. Dun, 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 dun. Okay, so I always encourage you guys to play around with these things when you're not too sure what's happening, or even if you know what's happening, right? It's the best way to sort of lengthen your knowledge that you've got here, extend on your knowledge. Okay, so let's look at the next one we've got here: rotated rectangle. Def rotated rectangle, and that takes a width, a height, and now an angle. Okay. I'm just going to give me a bit of space here. Okay. So this one says to draw a rectangle, but rotate the turtle anti-clockwise first by the given angle. Okay, so we got two steps here, I guess. We want to rotate our turtle buddy, and then we want to draw a rectangle. Okay. So if we want our turtle to spin anti-clockwise, as we can see here, it's spun anti-clockwise 30 degrees, right? So let's just have a quick thing about that. We know we can only turn our turtle left or right. So if we're looking down on it and it's turning anti-clockwise, then that means the turtle is going to be spinning to his left, okay? So let's get the left in there. we've specified our angle here. So we want to turn left by the angle, right? So let's just see what we've got going here so far. Rotated rectangle, 30 degrees. And okay, yes, you can see our turtle's sort of facing this way now, right? So it's spun 30 degrees. So that's definitely the right way. We're all good on that front. Now at this point here, we want to draw a rectangle, right? So you might be thinking, oh, okay, cool, I've already done that. Whoop-de-doo, I can just copy paste all this code in, right? And yes and no, okay? So we don't just want to copy paste this big chunk of code here, but there is no need for us to do this whole problem again because we've already done it up here, okay? So if we want to draw a rectangle, well, we've already written the function up here that can in fact draw a rectangle. So let's just reuse that function right here. Let's call that function, and we're going to want to call it with width and height, right? Because that's the width and height that we gave it in here. And so this step should rotate out our turtle, turn it a little bit, and then we should just draw the rectangle, okay? Assuming all our other functions work. Yeah, okay, so there we go. So he's turned a bit to the left. He's drawn the rectangle. And in fact, it's also finished facing east, I think, because this was, yeah, ensure the cursor finishes pointing east. And just because we did our rectangle one well, where we finished facing east, this function here is also going to finish facing east because we're calling rectangle inside it. Okay, so this is a really good example of how writing good sort of writing a function that does a really good job of doing a specific purpose can be really useful when we try and build up into other shapes, right? So we've done our rectangle, and that makes doing something like a rotated rectangle really, really easy, right? Because, I mean, this is 2 lines, right? We've just managed to reduce it all the way down to that. Okay, so I've got some hint this can be done in only 4 lines of code. Well, we did in 2, so, you know, take that tutorial. Oh, including the def. Okay. Well, 3, whatever. So let's see what we've got here. The next one is Polygon. Radius and num sides. Okay. So we want to draw a regular polygon with n sides and side length radius by sine pi over num sides. Okay. So remember what I was saying at the start about using things like turtle or maths, how that's not in Python by default? These advanced trig functions like sine and even pi, I think by default, isn't actually inside, isn't in normal Python. So for instance, if I come over here and I try and do sine 90, yep, it doesn't know what sine is, right? So we can see using the hints here that we need to import math. Okay, so I'm going to go back up the top and add another import, right? And we're going to grab the math module this time. Now the math module allows us to use these trig functions and pi and all that kind of stuff. So now that we've gone and grabbed all the maths functions, we have access to it. So just to show you, if we go into the shell, right, and we import math, okay, then we can see what's actually in the math module, right? So dir directory allows you to just see what a bunch of stuff that's in there. So we can see acos, ceiling, yeah, here's our cos, sine. Yeah, right, we've got some cool stuff in here, okay? So now we should be able to use math.sine 90. And it looks like our sine is going to be using radians instead. So actually, let's just try math.sine 0. Yeah, 0. Okay, there we go. Okay, now you'll notice I'm using math.sine, right? So even though I've imported the math module, it's working exactly the same way as the turtle module, right? Like I imported the turtle module, but I still have to do turtle.forward, or Python will think that I'm referring to a function inside this file. Okay, and that's really just more for safety, because imagine if I had 2 functions, right? I had a polygon here, and there was also a polygon in the math library, right? That doesn't seem completely unreasonable. Then we would want to make sure that when I talk about polygon, I'm talking about this one. And when I talk about math.polygon, I'm talking about the math library one, okay? So that's why we always want to sort of preface these functions with the module they come from, okay? So I have imported my math. I have my turtle going. Cool. So now we should be able to set up some stuff here. So what do we want? Which draws a regular polygon with n sides and side length. Okay. So our turtle is just going to draw a side, turn a bit, draw a side, turn a bit, draw a side, turn a bit. Okay. So straight up, it looks like the couple of things we're going to need is how far is our turtle going to go? So I guess I'm going to call this guy side. Okay. Now we've got our radius there. we've got our num sides here, but like I said before, we definitely need to be using math.sign, and I'm 99% sure that that will throw a weird error if we use that pi symbol. So I'm pretty sure there is a math.pi. Let's just go back into the shell quickly. Was there a pi in here? Pi, there we go. So math.pi. Yeah, cool, there we go. Okay, so we're going to use math.pi. So there's our side length, and I guess we also need the angle that we're going to want to turn. So let's think about this. Our turtle's going to turn, and then eventually end up facing the same way, right? So he's going to end up facing the same way he started. And we can see in the hint down here, the turtle will move a total of 360 degrees. Now, since every single one of these turns in the angles is the exact same sort of magnitude, right? Every turn, we're always turning the same amount because we have a regular polygon here. This essentially means we're going to be turning 360 degrees across however many turns there are, right? Now, since we know how many sides there are, the number of sides is the same as the number of angles, right? So this is how big our turning angle is going to be. Okay? And then I guess essentially at this point, we want to move our turtle forward, and then we want to turn our turtle to the left. Okay, so let's start having a go with our polygon here. So what do they have in their example one there? 107. I'm just reading these off as I go. Okay, cool. So he's drawn the first side, and then he's turned up a bit. Let's up this a little bit. And so essentially, I guess what we want to happen, right, is we want our turtle to sort of keep drawing these sides. Yeah, see, there we go. It's going, it's turned, it's going, it's turned, it's going, it's then turned again one final time. Okay, but this doesn't really help us, right? Because we don't know, I guess, before we get into the function, how many times we need to copy paste this line. So what we need to use here is a loop. Okay. Now there's two main kinds of loop. For in loop and the while loop. Hopefully you've seen both of these in lectures by now, or if not, then in MyPy. And so I'm going to start this off with a while loop, right? So as you remember from doing a while loop, we're going to need some sort of counter. So I'm just going to call that guy I and start him at 0. And then we need to have some sort of loop that essentially says, well, I need to do these two lines of code, how many sides there are. Okay, so if there are 4 sides, I need to go forward and left 4 times and draw a square, stuff like that. So what we're going to do is we're going to set our I, while our I is less than our num sides. Right, remember we need to indent in after our loop. Then we want to go forward and left, and then forward and left. Okay, so let's put this in and just see how we're going for the moment. Oh, yep. Oh, he's still going. Oh, he is just going forever. Okay, so our program is not ending. Ooh, I'm going to have to stop you there, turtle friend. So we can see that our loop is actually running forever. And yep, okay, so we see that while I is less than num sides, but I is 0, right? And 0 is always going to be less than 7, I guess I put in. So I also need to remember to increment my counter each time. So it should be 1, then 2, then 3, then 4. Okay, so let's try this now. Yeah, cool, there goes. That's our little turtle friend, and then he's done. Okay, let's try this with a couple of other shapes. Let's try a square. Cool. Let's try something thick. What is this, like a dodecahedron or something? I think that's what a 50-cent coin is, or maybe it's 20 sides. I don't know, one of them. Let's find out. Yeah, and we can see that actually the bigger we make this, it almost ends up being like a circle. Yeah, smooth. Okay, so there's our polygon. Yeah, okay, cool. So that's one way we can approach this polygon problem, right? The other thing that we could do is we could have a quick think about using the other kind of loop, okay? So this here is a while loop, and this is fine, but I'm also going to show you how to do this with a for loop, okay? So typically while loops are used sort of more frequently when you don't know exactly how many times your loop is going to run, right? In this case, we actually do know how many times our loop's going to run, right? We want it to run num sides. And so what we can do is we can actually set up, using the range command, a for loop that will run num sides number of times. So this bit of code here will do exactly that. Okay, so we want to go forward side and we want to go left angle. Okay, and I'm just going to quickly run this again to show you that it's doing the same thing. See, there goes our little turtle. And it's doing the exact same thing, right? So what's actually happening here? The range command, essentially, if you just put range and then one number in there, it basically gives you back something that's going to allow you to count from 0 up into that number. Okay, so if I just go into the shell here, for I in range 10, let's just print our I out. Okay, we can see 0, 1, 2, 3. So it's counted from 0 up until 9. Now, in this case, we're not actually particularly interested in our I value, right? We don't need to keep track of this guy. But we will make sure that our loop sort of terminates after num size number of times. So this is a sort of more concise, clean way of doing this, where we have a fairly sort of, right, it's 3 lines, it's self-contained, we don't need to worry about this little I guy hanging around at the end, right? And it's just a bit cleaner, really. So I would encourage you to use a for loop when you have this exact number, and then use the range command. But like I've shown here, right, they both work exactly the same way. So it really is a personal preference thing. Ooh, look at that turtle go. But I'm actually going to call this part 1 for now. And so stay tuned, guys, and we'll be right back with part 2.